You're listening to Cool Air Hot Takes.
Welcome to Cool Air Hot Takes. This is the podcast about anything and everything from the built environment, from HVAC to data centers to supply chains and decarbonization. You name it, we're covering it, or at least dabbling in it, as my guy over here, Dan, would say. We're your hosts. I'm Charlie Jelen, along with my guy across from me, Dan Gentry.
Every couple of weeks, we get together and bring you the latest in HVAC news headlines, an expert interview. This week, we have the Director of Project Management for Autodesk, Ian Molloy. Special thanks to Victor Marisala for helping us get connected. So thank you, Victor, for that. Autodesk is one, if not the world leader in 2D and 3D design software. And we're going to be talking about new trends in modeling, what's up with digital twins, and when we'll be able to take a picture of a building and have Autodesk turn it into a 3D model, which sounds pretty cool. And I'm going to be back in the factory, so make sure to stay tuned for that one. And of course, we'll wrap it up with your stat of the day.
All right, hot take time. What do you got?
So, my hot take has to do with the season that's coming upon us. It's starting to get pretty cool out.
Yeah?
My hot take is you gotta have a heated mattress pad and flannel sheets, or you are missing out, my friend. My co-host is shaking his head. I feel like I'm like a warm sleeper too, like it nice and cold in there, but go to make the bed the other day. My wife got these new flannel sheets and this thing was on there and had cords. I'm like, oh, what is this thing? I'm trying to tuck everything in. And like, it's got dual temperature zones. So each side gets to pick their temperature, so put it on low and laying there sleeping. And boy, oh boy, is this the ticket? My son is like, I want my bed to be cozy like this bed. And he just has an electric blanket. I guess that's not good enough. But man, game changer. I'm going to say heated pad, flannel sheets, change your life. Charlie disagrees, but I love it. Thank you, Amber.
If we were playing hot or not, I'd go not. I'd go heavy not on this one. I'm exactly the opposite. Shorts, t-shirt. I've got a fan called a bed fan that like kicks air underneath the sheets.
Wow.
I like it nice and cold.
All right.
I'd be sweating like crazy in your setup.
Well, luckily we don't
Sweat fest.
sleep together.
At least very often.
What do you got today?
Okay, my hot take is there's a lot of communities that are concerned with the amount of water that data centers are using. And I think there's some misinformation that's going on about how data centers are designed and constructed today. And so today, operational data centers, they do use water. There is a lot of data centers out there that use evaporative cooling through cooling towers that are consuming water. Most data centers that are designed today that are being installed do not consume any water at the site itself. There are still some that are, but the vast majority, like of the data center designs that you see, how many of them are all dry?
They all want to not use water.
Right.
It's like a big driver for the design.
Now, there is a trade-off there because you use more energy when you don't use water at the data center itself. And energy production does use a lot of water. All right. The worst type in terms of water consumption of energy production is coal power plants. They use a lot of water. They withdraw a lot and they actually don't repurpose a lot of the water they use. So coal is the worst, nuclear is the best, and then natural gas is the third. And then you've got your renewables that consume nothing. Solar and wind do not consume any water whatsoever. And so a lot of this is like a balancing point because you can reduce the amount of energy that data centers use by using water at the data center. But that just pushes it to the power source. The power plants themselves can have a couple of different options that they can go at in terms of how much water they use as well. And so there's a balancing point in here that I think we have to kind of come to grips with. Now, I'm not saying that every community needs to adopt data centers, but if the pushback is water consumption only, I think there's a path forward where we can kind of all come to an agreement that this is a good way to go.
I like it. That's a huge thing. It's like the water use is like the big thing right now. It seems like, and everybody's talking about it, and people that are aware of data centers are talking about it, concerned about it, and it's like, guys, there's definitely opportunities to optimize that.
100%. And any community can push back. And I'm not saying there's no reason not to have a data center. There's communities, justifiably so, that do not want to have data centers in their backyard. But I want to make sure that the right information is out there where people are making these decisions based on.
Nice little PSA there.
There you go. All right, next up, HVAC headlines.
HVAC Headlines. Your news today.
All right, listener, it's 11:30 in Princeville. Here's your headlines. Headline number one, we're going to go across the pond and see what the Brits are up to.
What are they up to over there these days?
All right, well, this is from the BBC. Headline number one, experiment finds yogurt can lower house temperature. So, Dr. Ben Roberts is a senior loughborough in healthy buildings at, our producer is going to have to help us or correct us on this one. I believe it's pronounced Loughborough University.
Loughborough University, yeah.
There you go, listener. You heard it from the source. He said applying yogurt to the outside of windows can lower the indoor temperature by up to 3.5 C.
It's kind of a significant number.
His team took two identical houses at the university and put yogurt on the windows of one house and nothing on the windows of the other. According to the good doctor, the yogurt forms a thin film on the window and reflects some of the incoming solar radiation as the yogurt is light, it's white in color. So I had some questions. First of which, what about the smell?
Yeah, that's a great question.
Well,
yeah.
It gets answered in the article. He answers
Nice.
he answers that in the article. Dr. Roberts said the yogurt smells for about 30 seconds while drying, but as soon as it is dried, the smell disappears.
30 seconds. It's pretty quick.
Second question I had is, what type of yogurt are we using here?
Naturally.
They also broached that subject. They say they used Greek yogurt with a 10% fat content.
Very specific.
Mm-hmm. The article concludes that Dr. Roberts was pleasantly surprised as he did not think it would be that effective. I also agree. I am surprised that this even happened.
How effective did he think it was going to be?
I don't know.
How do you apply it?
You're just out throwing yogurt at windows.
Do a little schmear.
So if you've got some extra yogurt laying around, throw some on your windows. You can save some energy. Also, you can go to like any big box store and grab a window overlay that's made to reflect the sun, the radiation, and it costs a couple dollars a roll.
Seems a little more practical.
But yogurt works too, apparently. So
yeah, that is great.
Headline number two, residential shipment and HVAC sales tumble. So this is from HVAC The News. It was a tough start to the year for the residential side of the business. So shipments of central air conditioners and heat pumps tumbled in July, down nearly 27% compared to the previous year. This is according to AHRI data. AC units took the steepest hit, falling more than 30%, while heat pump shipments dropped 18%. Carrier is projecting a third quarter residential volume to be down over 40% year over year. Its sharpest decline in more than 10 years, which is crazy because that included COVID. Trane is expecting over a 20% drop, and Lennox points to tariffs, refrigerant shortages, and weak home sales as major challenges. Still, distributors like Watsco say the pricing is holding steady, and they're investing in contracting programs now to help drive replacements when demand rebounds. Most of these leaders expect this to happen in 2026.
That's pretty big. Do you think like the refrigerant transition had a big part on that? Like the costs got high, and like our buddy Deke, he got a new AC. Mr. Deeds got a new AC in his house. This was several years ago now, but not like that long ago.
Yeah.
And I think it was like $3,600 or something like that, if I remember right. But I mean, that's like $10,000 now. And it's like,
I think tariffs hit all of this stuff pretty hard. The refrigerant transition, the DOE energy transition kind of coming at the same time. People aren't building homes, apparently. Home builds are down. I think that's going to change. I think mortgage rates are coming down. I think people are going to start building more homes or purchasing more homes or updating
Hopefully.
their homes. So I think it's going to come back. But yeah, it's definitely a tough end of the year for the residential side. All right. Up next, we have the Director of Product Management at Autodesk, Ian Molloy. Don't go anywhere. Hey, Dan. Ever thought about how better training could make a world of difference for the HVAC pros out in the field every day?
you bet, Charlie.
Well, Trane Symbio 700 training is here to do just that. At Trane, we understand that proper training is crucial to getting the job done. This training is designed specifically for technicians and contractors to help them master rooftop units and split systems, all available on demand and completely free.
So, we can help contractors ditch the guesswork and focus on getting the job done right?
Exactly. Head over to trane.com/Symbio700 training to dive into the latest training program from our experts at Trane. All right, listener. Today we've got Ian Molloy. He's the director of product management at Autodesk. Ian, welcome to Cool Air Hot Takes. How you doing today?
Hey, Charlie. Hey, Dan. Yeah, great.
All right. Well, I picked up on a little bit of an accent there.
Just a little, yeah.
A wee bit. So none of us have met before, listener. So to get a little bit of a background, a little personal introduction, why don't we start with what are your favorite things to do outside of work?
Oh, right. So if I get proper downtime, which I don't get a lot of, it's video games.
What? Oh, what do you play?
So I'm a big fan of the Assassin's Creed franchise.
Mhm.
I've played all of them multiple times, like to completion. So I'm one of those guys.
How long does it take to get through an entire Assassin's Creed?
Well, like the recent ones, it could be like 250 hours.
Do you have like friends, do you have mates, as you probably call them, that you play with?
Well, actually, yeah. My best mate, my wife, she loves it too. And so we sit together
way.
and
You gotta be kidding me.
yeah,
Oh,
it's
that's
awesome.
great.
Like, and so, yeah, we sit there and we take turns and we sort of play through. We like to play it the same way and stuff like that. So it's pretty good fun.
That's awesome. All right, Ian, where are you from? Where do you live right now?
So I'm based in Boston, but I'm originally
Okay.
from Dublin in Ireland.
Awesome. How'd you get to the States? Did Autodesk bring you here, or is it a different job?
Yeah. This opportunity came up. I had the choice to go either San Francisco or Boston. And I chose Boston because that's where the main center of Revit development is. Really
all right,
wanted
cool.
to be heavily involved in that.
Well, we're going to get into the Autodesk side of this, but before we do that, the name of the show is Cool Air Hot Takes. We ask all of our guests that come on to bring a hot take. It could be from your personal life, professional, anything in between. You got a hot take for us today?
So it's a professional one. And so my hot take is the industry has only scratched the surface with BIM.
Oh, really? Okay.
Mm.
Where do you think it's going to go?
Well, in the US, a lot of Northern Europe, there's been a big move from CAD to BIM over the last 2 decades.
For the listener here, just to give us the full explanation, CAD to BIM, what's that mean?
So CAD computer design is generally, that's the expression generally means 2D CAD, right? So you're basically drawing things on a page. With BIM, you generate drawings from a 3D model. So it means there's less errors, things are more coordinated with the other disciplines. So there's been a big move towards BIM in the last few decades. But then what BIM, or building information modeling, for anyone who doesn't know, what it is and how it's being used, it varies very widely in terms of the level of sophistication of users and the value that people are getting out of it. So for the most part, people are using it mainly for documentation. We even see people sometimes, they've got this 3D model from the architect in the background and they'll use line work just to draw duct work, right? It's like,
Sure.
it's the simplest
Yeah.
thing you could do, but it's not really a terribly intelligent model, right? Of course, at the other end of the spectrum, we see people do very sophisticated things, build very complete detailed models. Now, more recently, and this is where our partnership with Trane comes in, there's been a lot of growth around the use of BIM for analysis. So, early stage load calculations, system sizing and selection, energy analysis, lighting analysis, airflow, all these kinds of things. It's very exciting.
Let's take a step back here and make sure we give the audience a little bit more of a picture. So why don't you give the listener, who is Autodesk and then what do you do with them?
So yes, Autodesk is probably most famously known for AutoCAD. That's what the company was founded on in the 80s. But today, we have something like in the region of 130 separate standalone products that you can, license individually or together as suites and subscription and so on.
That is way more than I would have thought.
Yeah, but remember, we serve multiple industries, right? And of course, in AECO, Revit is the kind of flagship hero product, as we call it. And so as a product manager, kind of like to describe it as a little bit like air traffic control, where you're sort of navigating traffic between our customers and our users and their hopes and dreams and expectations and needs to, deliver more stuff faster, better quality. And then our development teams, and then also our business. So that's pretty much the job of a product manager, is to sit at the cross section of that and try and manage the traffic between those things.
What products are under your purview?
Yeah, so I am one of a number of product managers that look after Revit.
For the people that are not familiar, can you give us a quick, what is Revit?
So Revit is a building information modeling software. You don't just draw lines on a page and point at it and call it a duct or a pipe. It's an object modeler, right? So you draw an object that represents a duct or a pipe. Each of those objects have properties and behaviors that carry certain data, maybe things like the size or the pressure loss flow for a pipe or duct and things like that. But then also when you chain them together, you create a system, right? And it's a parametric modeler. So for example, as is known to happen, if an architect changes the level of a ceiling or a floor or something like that, you don't necessarily have to go manually change everything. You can change the level and everything updates.
It's always the architect's fault,
Yeah,
right?
it's-
That's what
yeah.
I've been told. No, I'm just kidding. I'm just kidding,
A
architects.
moving target date. Yeah.
All right, so I want to get into the prefab side of this, but before we do, can you connect some buzzword dots for us? So BIM and digital twin.
So BIM is maybe more of a process, right? It can represent a lot of things. It can span the whole process from planning to design to construction and operations. Digital twin is more of a thing. It's a noun, right? And the idea is a digital representation of a physical thing that exists in the real world. It could be just a physical twin so that it looks like it, but increasingly, the real value is in a performance-based twin. So you can think of it like a digital twin of a chiller. And you guys will know what that is, right? You can actually, in parallel to metering and monitoring the twin, you could also simulate its performance and compare them, look for deltas, predict failure, things like that.
Who else creates the model that ultimately becomes the digital twin?
Well, first of all, digital twin is still an emerging thing. It's not like everyone's doing it, right? But anyone who creates anything in 3D, so, SketchUp, Rhino, ArchiCAD, I'm just naming some of our competitors and so on. And bear in mind as well, a lot of these tools work together. When you create a digital twin, in fact, even with something like our digital twin platform like Tandem, you can combine data from a Revit model and then also a model from a third-party vendor to create an aggregate. Because not everything is modeled in the one tool or in the same format, but you still want to bring it together in one space and sort of give it meaning and put context on it.
Interesting. Okay.
Yeah, that is super cool.
Yeah, that is. Yeah, it's an area that I've just always in my head. The digital twin had to basically start from a BIM model. Otherwise, how do you assign all the attributes and the performance side of it?
If you think about a digital twin more on the physical side, yeah, you've got the modeling, but there are digital twins of, let's say, chillers that don't need the physical model. It's a mathematical model, a physics model, right? That's equally digital twin as something that, clearly looks like with the right rendering engine would look like the real thing. So there's physical twins. And in fact, in the world of digital twins, there's this sort of construct of levels of sophistication again of digital twin. Now, this is not my main wheelhouse, but they start at sort of simple physical and they end up at kind of highly intelligent performance feedback loops kind of thing with being able to predict the future and stuff like that. And this is again where AI can play a big role.
But let's get back more into what's underneath you and what you're responsible for. What are some of the new features, new trends that you guys are tapping into with the products that you're responsible for?
I'll stick on topic and stick with the MEP side of things. So our strategy for some time now and continues to be really connecting the workflow from design analysis through coordination and documentation into detailing and fabrication. There's capabilities in Revit that support each of those stages today for both mechanical and electrical and subdisciplines, depending on how you want to break that down, but just very simply that the two main ones are mechanical and electrical. And so, yeah, there's capabilities in each of those boxes and they work in their own way, but there's differences between them and they're not necessarily as connected as they could be. And so the big thing that we've been working on over many years and continue to do is we still try to give every user, whether you're mechanical, electrical, a designer or a contractor, every release we try to improve things. We also try to improve the connections between those things, the integration, because the flow of information is really the single biggest thing that causes rework or errors or things like that. So we really feel the greatest productivity benefit and quality benefit to the end building is in really being able to iterate through that loop really rapidly and so on. So that's our kind of reason for being. In that regard, we've been developing a lot of improved analytical features in Revit. So for example, the ability to translate an architectural model into something that can be analyzed for heating and cooling loads and energy and so on. We use that in our own built-in load calculations and energy analysis that we provide as part of Revit that we use the Energy Plus engine with. And then this is where Trane is building on top of that and sort of extending. What we do there, I describe as kind of vanilla. It's good quality, but it's fairly simple and there's no real extra expertise or specialization in there. The thing that we're excited about with Trane, of course, is that with Trace, they've been doing this type of analysis for 50 years. It's the de facto standard. And they've really been innovating because they went from Trace 700 to 3D Plus and now pushing it further with this new partnership. And That way we can support really a spectrum of users. And what Trane really provide is that really high level of expertise, particularly on mechanical system sizing, energy analysis, and things like that. And they can bring that very high level of precision on things like equipment performance curves, even down to like how engineers like to see load reports and sizing reports. Like Trane kind of own the standard for that. And then of course they have a level of technical support that we can provide. If you want to know exactly what the right kind of pump or fan performance curve should be, don't ask Autodesk, right? So that's where Trane's expertise is.
Yeah, I shout out to our friends in CDS. That's where I started in the company. I started modeling on Tray 700. And it was always such a crazy thing because in my head, you have the architect who's building this beautiful 3D drawing, and then you hand that over to the mechanical team, and they have to remake that entire building in a load software and then an energy software just to do the exact same workflow. And there was always this like, why can't we connect these things? And it's finally happening, which is great.
Yeah, it's still not perfect, but I will say, over the last few years, and particularly with our partnership with Trane, it's getting a lot better. And in fact, this is where I'm getting, long story short, I've got some really exciting features coming up that improve this. We've been improving it continuously, but they're just getting better and better. And of course, Trane is really extending on top of that.
One of the areas that we see a lot is trying to build as much of a facility offsite and then assemble on site, or even go from like Lego blocks to Duplo blocks for those with kids, the little Legos to the bigger Legos. Are you using Revit to do that prefab manufacturing?
We're not, right? But our customers are.
Yes.
I'll actually say that in the world of prefabrication, there's lots of exciting stuff happening all over the industry, but MEP is really, really advanced because those products that I mentioned, SCAD CAM, or the new version of it that we have now in the cloud called the MEP Content Editor, it's a much easier way to get started with those tools because these are kind of older legacy tools. You can kind of think of it like Tray 700, like old interface, very powerful, old interface, not very easy to use for a newbie. We've kind of done the same thing.
You won't offend anybody on
right?
this
Yeah, no, I figured. But yeah, because of those tools, the underlying technology behind that has been around for quite a long time. And, certainly in the US, all of the leading mechanical electrical contractors, particularly on the ductwork pipework side, are using that to model not just like individual segments of pipe or duct, but entire systems. And along with some of our partners, Stratus is a good one I'd shout out to. They're taking the Revit model that's been developed by a detailer and using the Autodesk Construction Cloud, they're putting a layer of functionality on top of that, which basically helps manage the entire fabrication process of things like work packaging, nesting, cutting, labeling, assembling, even down to sticking a label on it, shipping it to site. So they just install it, and it's incredible. So all of that is being done from model-based manufacturing. There's no paper anywhere in the building, and it's all being done from the model. And so, yeah, it's pretty incredible.
Yeah, that's really interesting stuff.
It sounds like a productivity revolution. Like once all this gets deployed, like it seems like you could build things much faster.
100%. I mean, that's why I said the industry has only scratched the surface with BIM, because we've used it for design for the last 2 decades, and it's increasingly been used in analysis. But yeah, particularly in the world of fabrication, because you're talking about hard, time and money. When people come to build things, you can relatively easily change ideas in design, or you might have that day where you've got to move that meeting room from one side of the building to the other. But in the physical world, a business could live or die based on mistakes like that, or the efficiency and the competitiveness that you can have. So the customers that are really embracing model-based manufacturing, they're seeing tremendous benefit in the predictability of their projects, their ability to win more work, do it faster with less resources, and then make sure that they're making a profit on these things. Because the great thing about having a really inefficient industry, and it's so clunky and inefficient, that there's tremendous savings to be had. And definitely in the contractor space, they're starting to see those benefits.
That's great. And one other thing you mentioned that is in your domain as a product manager is the sustainability side. Can you talk to us a little bit about what you guys are doing there? I got to imagine it's some of the work you're doing with Trane on the energy side, but probably more so on the embodied carbon side.
Yeah. So Autodesk's vision and mission is about making a better world, designed and made for all. And that is a sustainability message. Sustainability is such a big word. It can mean everything and nothing at the same time.
Oh yeah, for sure. Everybody defines it differently.
Right. Yeah. And I will say, Autodesk got a lot of exciting stuff happening in a lot of different areas, but in the buildings world, It spans a whole range of things. And it really, the best way to think about it is how it layers over the sort of whole design process and even our sort of product portfolio. Like before you even get into Revit, we have a tool called Format, which is really intended for very early stage planning, where you can understand not just the building program, but also do sort of cool optimization, like the number of parking spots. There's like literally an AI that will figure out here's the right number of car parking spots in this. But also doing things like, daylight analysis, airflow analysis, solar analysis, so that you can sort of optimize the building massing early on. And then also there's some embodied carbon analysis built into that as well, so that architects and engineers can understand at a very high level what the impacts of different structural systems, envelope, and MEP systems have on embodied carbon.
Like comparing concrete reinforced versus mass timber at a high level, what are we working with?
Exactly, yeah. And then further downstream, we've got a suite of tools there. The main one being Insight, another tool that I look after. And what it does, building energy analysis, and it does embodied carbon analysis, and it brings them together to create a picture of total carbon analysis. That's a very cool capability that architects and engineers can use, again, from early stage throughout the design. Revit model at any level of detail you can submit to it, and it'll get you started with understanding those things. It's kind of an open-ended problem though, right? Because, you can get into very, very fine level of detail for embodied carbon and different things like that, based on how you model things and then how you analyze them. And we're building, both on the Revit side and on the Insight side, a set of tools and capabilities to sort of support that varying levels of granularity, but then also doing it consistently from conceptual design in Format through to more detailed design in Revit, and even on into construction. There's also interesting things there. In order to do that type of work, we touched a little bit on the energy, I'll come back to it, but embodied carbon, the conversation historically in the last 10, 20 years around sustainability or LEED was typically around energy efficiency. And that's still very much a thing. And that's what we would now frame as operational carbon. But in the last few years, embodied carbon has really blown up as an issue that people understand better, and we have better data to analyze it, make better decisions on it. And so that involves not only just understanding the quantities and data from the building, but then also mapping that to known and trusted embodied carbon databases. So this is where we have things like partnerships with groups like Building Transparency and EC3, and there's various third parties that can do that type of analysis. And that's what we're using in the Insight analysis. And then, like I said, the other side of that equation is the operational side, where we do a certain amount of that operational energy analysis and carbon analysis and present those results in a dashboard. But this is another place where Trane are adding their layer of expertise to be able to go to that higher level of detail and precision around the particular impact that I'll say more modern, innovative HVAC systems can have an impact on that equation, right?
Absolutely. Yeah, one of the just basic concepts that we talk about frequently is low flow, high delta T, and how big of an impact that can have not only on the energy of your system, but on the embodied carbon of your system. And for the listener out there, when that happens, when you go to a lower flow and you go to a higher delta T, you can shrink the pipe size. And then the impact that has on the building as a whole. Smaller pipes, that one's pretty straightforward, right? It's just less material, but then you have less hangers, you have less reinforcement from the concrete. If you have a multi-story building, it impacts that whole stack up. But the ability to model that is incredibly complex.
Yeah. Charlie, you're touching on something that is one of my kind of pet peeves or something, but there's this, all engineering disciplines do it, mechanical, electrical do it, but you've heard of the moron principle?
No, I can't wait. This is going to
Yes.
When you're designing something, if you're in doubt, add more on, right? And, like I said, it applies in structure, it applies in mechanical. But, when I was in college, I obviously learned about designing mechanical electrical systems, and, we're using software to do this. And I said, yeah, in the future, everyone's going to be using software to really right size these things. And unfortunately, though, people use a lot of rules of thumb and they oversize things. It's the old, or even if they're doing some calculations, then they'll sort of add 25% on and pick the next size of equipment up and so on. And so, even Trane acknowledged that, like, okay, that might be great. We're selling a lot of equipment, but it's actually not producing the best, highest performing building, right? These equipment is cycling on and off too much, and it leads to maintenance issues and so on. But part of that challenge is having the tools easy and accessible and trustworthy enough for them to make the decisions to kind of really right size and look at the system sort of holistically. And I do think this is another area where mechanical, electrical engineers can play a big role in giving clients better value, upfront better value, and then also a better product, easier to maintain, lower cost, like you say, better embodied carbon. There's a ton of opportunity there if we can all just overcome the moron principle. Yeah.
All right, Ian, thank you so much for coming on. That was a really fun conversation.
Good. Yeah, no, thank you guys. That was great. Enjoyed it.
Thank you.
Hey there, listener. It's fun talking about massive 100,000-ton chilled water plants. Mr. Big Water Plants over here, Dan Gentry, is always talking about how big these water plants are. But I know most of you are working on smaller plants that have their own set of challenges.
Like getting to higher efficiencies or updating to the newest controls or dealing with tight retrofit constraints for aged equipment.
If this sounds like you, check out the Agility Magnetic Bearing Centrifugal Chiller. Compact size without the compromise.
Oh man, this chiller packs a punch, reducing installation costs and enhancing system performance. And now it's available up to 500 tons.
Ready to upgrade your system? Contact your local Trane account manager today or visit trane.com/agility. All right. Dan, are you ready for another edition of Dan in the Factory?
I am. It's fun stuff.
All right. If you're new to this, it's exactly what it sounds like. We send Dan on a little mission or an assignment to go meet people from across the Trane world, from our factories to our training centers. Dano, where'd you go this time?
So earlier this year, I was down at our facilities down in Davidson, North Carolina, where essentially there was a new opening for what we call the Advanced Technology Training Center. So it's where we bring technicians in and do training for them on various types of equipment that Trane manufactures. I caught up with Bryon Wilfong. He's the area service manager for the service department in Davenport, Iowa.
Nice.
And just kind of talked about some of the stuff that he goes through. Really what I wanted to try to do is kind of get a wild story, maybe an interesting story, a funny story. So check it out.
Probably my go-to one was when we started a chiller up in the University of Illinois, and everything was fine. It was great, and shook hands. Life's good. We took off. Got calls probably a week later. Says, hey, listen, every time I start your chiller, all the parking lot lights start to go on and off, and all the clocks in the classroom start to spin, and it's your chiller's fault. And I went, that's not true. And he goes, yeah, no, it's definitely true. We know. And I'm like, that's not a thing. And I said, listen, I will drive down there, and I will prove to you that you're wrong. And so the way to get to this college is you're on the interstate, and you take a right, and you go on this long drag. And I took that right, and I'm going down to their facilities management. The guy wasn't lying. All the parking lot lights are just flashing on and off and on and off. And I'm like, this is insane. So I go in, he shows me a classroom, and sure enough, the clocks are spinning. And I said, you think this is because of the chiller? He goes, if we go shut it down, it'll stop. And I said, prove it. And he shut it down, and it stopped. And it took a little bit. I'm making it sound like a condensed deal. Mm-hmm. But essentially, this old guy comes in, and he goes, he has a wooden box. He sticks it in an outlet while the chiller's running. He said, see, you're at 15, and you should be at 12. And I said, 15 what and 12 what? And he goes, you're at 15. That's too high. And I'm like, I don't know what you're measuring. And there's a little gauge and all this. As it turns out, the buildings it wasn't happening in, they had 2 steps of step-down transformer. Their whole clock system, which took care of all the clocks in the classrooms and all the parking lot lights and all of this, was actually on a high voltage system. And every hour there was looked like a car motor that would turn on with a weird looking alternator on top of it, and it would send a zeroing pulse, which would zero all the clocks. And that thing ran at 5 kilohertz. And do you want to know what the switching frequency of a centrifugal chiller was? About 5.6. So when that chiller started, it thought it was that zeroing pulse. And so sure enough, our chiller was definitely causing the lights to come on and off.
And that was on a VFD?
That was on a VFD drive. We ended up putting the largest line link reactors you've ever seen just upstream of it to muffle the harmonics that were backfeeding into their thing because... Yeah, it was truly our deal.
That is a unique one. I haven't heard of that.
You get in the industry, and there are certain times you get phone calls. You're like, yeah, that's not possible.
Chillers causing clocks to go crazy.
Yeah, and the whole lighting system, all the parking lot lights and everything, it looked bizarre.
That's a good one.
Yeah,
that's a good one. Chillers messing up clocks. It's a new one.
I can't believe like that. That is so wild. And how like high voltage or medium voltage was controlling clocks. That one's a little odd. I don't know how the electrical side of that is set up.
No, I'm the same. I'm not a Sparky, if you will, and that stuff confuses me. And
We need Andy Nardine. We need Andy Nardine to come back and help us. Shout out to Andy Nardine. I'm sure he's a friend of the show.
There we go. So yeah, it was a pretty interesting one.
I like it. Good job.
Yeah.
All right, up next, we got Stat of the Day.
Here comes your stat of the day. Stat of the day. Stat of the day.
All right, listener. Stat of the Day is from Visual Capitalist, one of my favorite sites for stats. Headline is From Harvard to Stanford, the tuition costs of the top 10 colleges.
Oh, okay.
This one caught my eye here.
It's a fun one.
College is out there. My oldest is 9, but you got to start saving early.
Yeah, I agree.
So we're going to go through this. The numbers we're going to provide are annual tuition only, nothing else. Guess some of the top.
I'm going to guess Harvard and Stanford just because it's in the list.
Yeah, it's
and
in
then I'm
there.
going to throw like Yale on there.
Yeah, good job. Good job.
It's got to be on there, and like MIT, top 4.
Nailed it. All right. So the average for 4-year public in-state school is $12,000. Number 10 in terms of the highest tuition is Harvard. I would have thought that was higher, but it's Harvard. $60,000. University of Pennsylvania, number 9, $63,000. MIT, good job. Number 8, $64,000. Princeton University, $65,000. Johns Hopkins, $67,000. Stanford, $68,000. Northwestern, $69,000. Number 3 is Yale, $70,000. Number 2 is Duke University, also $70,000. And the University of Chicago is number 1.
I would not have guessed that.
I would have never guessed that. $71,000 a year just for tuition at the University of Chicago.
Start saving your pennies, kid.
Do you know what what are they known for?
I was going to say, what do you get for that? I have no idea. I'm guessing there's something we don't know.
Well, there you go, listener. There's your stat of the day. Thanks for listening to this episode of Cool Air Hot Takes. Thank you so much for Ian Molloy from Autodesk for joining us today.
Don't forget to send us questions and, of course, hot takes by means of leaving us a comment on Spotify or YouTube. Leave us a review on Apple or drop us a message at coolair.hottakes@trane.com. Remember, we could be sending out some merch for some of those hot takes, so send them in. Don't forget, you can leave us a rating wherever you listen, 5 stars only, please. And until next time, stay cool and keep those takes hot.